Good afternoon and welcome to today's webcast. This is Pete Prokilo with Fire Engineering, and today's event, Standpipe Operations Part 2, Water from the Outlet to the Nozzle, will be presented by Bill Gustin, Captain with the Miami-Dade, Florida Fire Rescue Department. Today's event is sponsored by Key Hose, and Bill will tell you a little bit more about them in a few minutes. This presentation is both live and interactive. You can ask questions at any time by just clicking on the Ask a Question button in the presentation window. We'll get to the questions at the end of the presentation, so please hang in until we get there and Bill will take them at the end. If you're running pop-up blocking software, you'll need to disable it to view the webcast, and in addition, it's recommended that you close down all other applications for better performance. For your convenience, this presentation will be available on demand within 24 hours of the live event, and we'll send you a reminder email message with a link to the archive, and that'll be online for a year. You can also get to it from the homepage at fireengineering.com. Now a little bit about Bill. Bill Gustin is a 41-year veteran of the fire service and captain with Miami-Dade. He began his fire service career in the Chicago area and conducts firefighting training programs in the U.S., Canada, and the Caribbean. He's a lead instructor in his department's officer training program, a Marine firefighting instructor, and has conducted forcible entry training for local and federal law enforcement agencies. He's also an editorial advisory board member for Fire Engineering and FDIC, and was a keynote speaker for FDIC 2011. Bill?
Peter, thank you very much. I'm looking at these pictures from the Key Fire Hose Factory in Dothan, Alabama, and my endorsement of Key is very easy to make and very sincere because it's the hose that I use every day on my company. My company is blessed to use the best hose on the market that's Key Combat Ready. When we're talking standpipe operations, you need a hose that has great flow capability with minimal friction loss and minimal are great kink resistant. You cannot do better than the Key Combat Ready. So, having said that, we'll get to our presentation now, and here we go. Okay, all right. This is part 2 of a 2-part presentation. The first part concerned itself with system capabilities, limitations, maintenance, and nomenclature. Today, we're going to begin with talking about the contents of a standpipe accessory bag. What I'd like you to focus on in this slide are those metal rods at just about the maybe 1 o'clock position, those metal rods. And what we're going to do is we're going to look at pressure reducing valves. If you'll remember from my last presentation, which is archived, and you can bring it up, it was presented in July. There are 2 types of pressure reducing valves. There are the field factory set, and there are the field adjustable. So the metal rods in this case, on this type of PRV, would be inserted in that hole you see. And now, do you run the video? Because I would go to adjusting PRV, and I understand I can't talk while we run it. All right, Peter, are you going to run the video, or do I? Okay, that device is actually what the fire suppression system contractors use for adjusting field adjustable PRVs or testing PRVs. And their objective is to achieve a flow of 250 gallons a minute at a minimum pressure of 100 psi and a maximum pressure of 175 PSI. Okay, this is a different type of field adjustable PRV. And let me go to the next slide here. This one is, you can take the valve wheel off by disconnecting that big nut. Right, there you go. And it exposes that the 1 1/16 nut, which tensions that spring. And the spring in a PRV works exactly the opposite as it would in a pressure relief valve. In a pressure relief valve, on our appliances and on the intake side of our pump, the spring acts against the pressure. The spring in a PRV actually wants to open the valve, wants to pull open the valve. And the spring is working against the downstream pressure that would be accumulating in the upper bonnet. Let's see here. I think this is a good idea. When I did my last webcast, a fella introduced me to this. I think it's a great idea. I'm not going to endorse it here. If you are interested, send me an email or make it one of your questions. In this case, you have it labeled as when it was last tested and the pump discharge pressure that the engineer would have to pump if the building's fire pump failed, and you had to replicate the pressure at the FDC. All right, and here we are using the 1 1/16 socket to tension that spring. All right, now this is the contents of my company's Standpipe kit. I'm not a big fan of using Ys to operate 2 hose lines over a standpipe, and I'll state my case here shortly, but let's take a look at some of the other items there. A spare nozzle. I remember studying years ago for captain, and one of the texts was the Fire Officer's Handbook of Tactics, and John Norman at the time advocated that you take an extra nozzle with you in case that one should break. And I said, well, isn't that just a little bit of overkill? I said, it's a solid tip nozzle. What could happen to it? Well, here's what can happen to it. We did a standpipe drill a few years ago. There was a water main break down the street. Gravel accumulated in the pipe going into the fire pump up into the standpipe and jammed the nozzle so badly that we actually broke the bail control to the ball, and we needed a separate standpipe. There you can see my friend Ray Bell holding all the gravel that accumulated in that that nozzle. Let's take a look at some of the other things here. We see a kind of a 2-pronged wrench, an elbow, an inline gauge. The bolt cutters, a lot of your zone control valves for sprinklers that are piped off the sprinklers, the standpipe system, will have be bolted, chained, and locked shut. The Allen wrenches are to disable or circumvent a PRD. That would be a pressure reducing or restricting device, a pressure restricting device like a restrictive orifice or device that would prevent the valve from being opened all the way, and that controls the pressure only in flow, not in static. Door chocks. If you'll see they're the type that hang over the hinge. In a high-rise fire, it is best not to open and chock every door you go through. You lose the pressurization effect of the HVAC system, and you provide an open pathway for the contamination of smoke. The only door that should be wedged open in a standpipe attack would be the doors that the hose line is passing through. The others should be ajar or unlocked and accessible, in other words, not locked. But the best way to do that is either with a hose strap or that hinge hook device. All right. This is the 2-pronged valve wrench being used by one of our brothers on the West Coast. And this is a bull ring. It's a device made primarily for handling 2.5-inch line, but it also makes a handy standpipe valve wrench. What we see here is a 2.5-inch line with an 1.125 tip nozzle. And it is connected to what we call a increaser. That would be 1.5-inch female by 2.5-inch male thread that is then, in this case, connected to a 2.5 to 1.5 to 1.5 gated Y. More commonly, it would be connected to a section of 2.5-inch hose. I'm not a big fan of this Y as you see it because it restricts you to the use of hose that has 1.5-inch couplings, and also you can't lock the valve handles. But the purpose of the slide is to show you the use of the increaser. This is a iron pipe, the national standard thread adapter. This is used primarily in buildings that are under construction that may not have the adapters to national standard or whatever the local jurisdiction's thread is at the time. All right, there's that giant boat anchor. If you're going to carry that Y, if that's what your department requires, and mine does, I think the best way to carry it to distribute the load is connect it up to the pigtail and carry it like a bandolier or a sousaphone. In other words, it goes over your shoulder. Now, where I really think the Y is useful, most useful, is in an office occupancy where the chances of you stretching short is fairly good because you have no frame of reference with familiarizing yourself with the floor below. Hence, you don't know where the fire is or the path to reach it. So you could stretch short. So in this case, what we're looking at here is that outlet 1 is feeding the line going to the fire. Outlet 2 is connected to spare hose, say 150, 200 feet of hose. If the company runs out of hose, make sure they're in a position where they can take refuge, have them shut down the line. You shut down the line on discharge 1, rapidly disconnect it, rapidly connect it to the unused hose on the unused discharge, and recharge the line in a matter of seconds. That's what I like using a Y for. Not so much for adding a second line. Let's talk about the inline gauge. The inline gauge reading is absolutely meaningless unless you are flowing the nozzle. Do not let head pressure in the standpipe system or the jockey pump fool you. If you flake out your hose, fill the line, and just barely crack it to bleed the air, you could be fooled by, as I said, head pressure in the standpipe or the jockey pump. You have to be flowing the line. Okay, there is another type of inline gauge that is combined with a flexible elbow. This department, you can see it has an increaser in the female connection and also has a section of radiator hose that is protecting the gauge. Here you see that somewhere you're going to have to charge this line and read the pressure as you're flowing. And I will be the first to tell you, that is a challenge. You cannot wash the grandmas down the stairs if there's people evacuating the stairs. You definitely don't want to direct any stream into an electric meter room or a elevator shaft. So whatever you do, you better do it quickly. All right, we're going to show this video, and for the purposes of education, for instruction purposes, we're going to go about this slowly, gradually bringing the pressure up. In reality, you got to be fast about this because where you throw the raw water is a critical consideration when you're flowing the nozzle and reading the gauge. Go ahead with the video. Again, you're going to have to do that fast. You're going to have to do that fast, but it has to be done. Static pressure is meaningless. Now, what about this device? This is a gate valve, and you have to be careful using it on a standpipe because a lot of these gate valves are rated only for 175 psi, and I know that there's some wiggling room in there with a safety factor, but I like to use this in lieu of a Y, in replacement of a Y, to add a second line off of a discharge. Remember that the NFPA 14 requires a minimum flow of 250 gallons a minute per 2.5-inch outlet. Now, it requires a minimum flow of 500 gallons a minute per standpipe, but that is $250 per outlet. And you know, and I know that you can get a lot more water out of most standpipe outlets, even PRVs. But unless you flow tested the standpipe, anything more than $250 is per outlet is a gift. So what we've done here is we've moved. We were on the floor below the fire. We already have one line in operation. We've connected a section of 2.5 to the outlet 2 floors below the fire, brought it up to the landing, and now this firefighter can look and control the valves of both hose lines. So what we're going to do is we're going to look at how we would operate 2 hose lines. Okay, cardinal rule: get the first line stretched first. Get it stretched first, so it doesn't get tangled up with the second line. Staff it with adequate personnel. Get the first line in operation first. With one line flowing, when you open the second line, you're going to have a precipitous loss in pressure, because, and essentially, you're stealing water from the outlet, especially if you are if the fire pump is delivering water to the building. It's not as serious a problem if you are pumping into the FDC with an automatic pressure control governor, because it will maintain the pressure to a point. But don't put blind faith in this. You've got to be careful when you open one line. You got to look back on the gauge of the other line so you don't steal water, and you got to balance these pressures. In order for you to have the proper pressure on both lines must be flowing. Again, I can't say it enough. Static pressure is meaningless. Okay, let's run the video, 2 lines from a standpipe.
Good screen. Kill that. All right, and then attach second line. Fully open this valve bridge all the way. $75 on volt?
No. I'm 75 now.
Yep. Okay, hold it. Walk line.
Okay, if you're wondering, that's key combat ready 2-inch hose with 2.5-inch couplings, and we will examine the choice of hose lines, the size and of hose lines a little bit later. I just have to wonder, I don't know who supplied this video, but you'd think that they could get a younger, better looking guy. That guy that was operating the valve looked like he came out of, escaped from a nursing home or something. I don't know where they got that guy. Okay, let's look at another device and that we might be taking with us. Okay, the floor below nozzle that's been developed by both Chicago and the FDNY. primarily for wind-driven fires where you cannot initiate a frontal attack because there's no amount of water that can beat a wind-driven fire. The blankets that are used extensively by the FDNY, again, for a window on the windward side. Now, it was suggested to me by Chief Peter McBride of the Ottawa, that would be Ontario, Canada Fire Department. If lowering down a blanket to cover the windward window is a good idea, why don't we lower down a Bresnan distributor and let the wind carry the water in? And, you know, when we hear something that's somebody else's idea, you want to say right away, that would never work. Well, we went back to our training tower at our training center, and we put our mobile ventilation unit that's on a trailer to simulate a wind. And believe me, I know a little bit about hurricanes, and I stood in that window, and it felt like a wind-driven hurricane was hitting me with about 75-mile-an-hour winds. So I think the next one here, just another picture of that. Okay, here, I keep forgetting to use my arrow. Okay, believe me, it felt like a hurricane hitting you in the face. Okay, go ahead and run the Bresnan wind video. So, Pete McBride, if you're watching, and you probably are not, but I have to give credit where credit is due. It's a brilliant idea, and you'd think that it would be hard to manage. It's not managed. The Bresnan beautifully equalizes the pressure, and actually the stronger the wind, the better it would work. Let's talk about the size of the hose, and this is always seems to be a controversial issue when we're talking about standpipe operations. Okay, what I don't want to hear from anybody is, well, we cannot use hose any larger than 1 3/4 because we don't have the staffing to operate a larger size hose line. The number of firefighters will be dictated by the size of the fire. The size of the fire indicates the size of the hose. The size of the hose indicates the number of firefighters. The number of firefighters does not indicate the size of the hose. The fire is a unsympathetic chemical reaction that doesn't care how many firefighters you have. There's no question that it takes considerably more firefighters to operate a 2.5-inch line than, say, a 2-inch or an 1 3/4 line, particularly in long stretches with a lot of corners. There's no question. If you don't have the firefighters, seriously consider not opening that door in the stairwell and filling it with a chimney until you do have enough people. So let's take a look at 2.5-inch hose. There's a lot of departments that mandate that 2.5-inch hose will be used at every standpipe operation, and I have respect for that. I respect that, and I can understand their argument, and it's a valid argument. Let's take a look at some of the hydraulics here. This is departments that are using 2.5 are typically using an 1 1/8 tip, flowing about 265 gallons a minute at 50 pounds nozzle pressure, or departments like Chicago that use an 1 1/4 tip on their pipe, as they would call it. That's a lot of water. So where would this be indicated? Where would the 2.5-inch line be indicated? What about a commercial occupancy where you do not have compartmentation? In other words, the whole floor is one giant fire area. The size of the fire area is immense, and the combustibility of the modern office workstation, which is basically plastic foam, plastic fabric, is highly combustible. Your work areas are surrounding a core. The only compartmentation, means of egress, and area of refuge in these center core office buildings is that core. What we're looking here is a building, a floor on an office building that has not been built out. So you're looking at the center core. We had a great opportunity a few years ago. They were going to tear down a center core office building on the Miami International Airport property. So we began our simulated attack with a portable master stream, and this is us flowing it on the floor below, checking our quality of our stream and checking the inline pressure gauge. And then we had the fellas bring the line up to the fire floor landing, and let me back up one. And then we brought it up. We knocked down the simulated fire, and if there's anything good about the open or the common ceiling plenum, is that there's really nothing to block your stream. You rip right through the hanging ceiling, and if you could get a few of these portable master streams in operation at fire floor landings at every stairway, that may be your silver bullet. At this point, in our scenario, we say we brought the fire down to size. Now we're going to go to the fire. So we put out all the fire we could do from the stair landing. So we connect up a 200 feet of 2.5-inch line, flake it back down the stairs. We got our 1 1/8 tip that we could spin off and have 1 1/4 if the water's available. And the fellas take the line down the hallway. Notice, no one's crowding the nozzle. Everybody has their job to do to move this line around corners. Operate the line into an office suite. Knock it down to the point that our medic rescue company comes up with 1 3/4 hose, stretches it out, connects it up to the breakaway tip of the 2.5-inch line. We lash the bail open so we don't accidentally kick it shut with a tubular webbing, and the fellas operate an 1 3/4 line for overhaul. This is an operation that we performed at a drill at the Riviera Hotel and Casino in Las Vegas, Nevada. The scenario here was we knocked down the bulk of fire and then used the portable master stream, the valve of the portable master stream, to control the flow of 2.5 or 1 3/4 or 2-inch line. So what you see connected to this is a Y. The other place that you would use 2.5-inch line would be in an atrium, where you would have a large potential volume of fire, especially if it was filled with kiosks or display booths that may exceed the design flow of the sprinkler system. Let's look at the hydraulics of the 2.5-inch line when it's connected to a standpipe. On my job, if we're stretching 200 feet of 2.5-inch line with a 1 1/8 tip, we're going to be operating at a nozzle pressure of 50. We will have a friction loss of 25 per 100 feet. I'm sorry, we'll have a friction loss of 12.5 per 100 feet at 265 PSI. Since we have 200 feet off, that would be 25, 12.5, 12.5. We're on the floor below the fire, so we add an additional 5. The magic number is 80. Another place where you should think seriously about using 2.5-inch hose and nothing smaller would be buildings that were constructed or had their standpipe systems installed before 1993. In that case, they are rated to flow a maximum per standpipe of 500 gallons a minute, but the pressure is 65 PSI. And that's a strong argument for using 2.5-inch all the time, is that you may not achieve a flow any greater than 65 PSI, especially at higher flows where you're approaching the maximum capacity of that standpipe, which would be 500 gallons a minute. If you're flowing less than that, of course, you probably will have more pressure available to you. Okay, another place where I would think very seriously about using 2.5 and nothing smaller would be your pressure-reducing valves. Due to lack of maintenance, due to lack of testing, due to them being installed on the wrong floor, you may have pressure limitations, and you're going to want the hose that will give you the minimum friction loss, and that would be 2.5. A lot of jurisdictions, including mine, when a high-rise building is under construction, it is only required to have one functioning standpipe. Now, if you've got a building with a huge footprint, you're talking about one heck of a stretch. I don't know if you want to be stretching anything smaller than 2.5, when you may have to stretch a considerable amount of hose to reach the fire from the only functioning standpipe. How about 2-inch hose with 2.5-inch couplings? A lot of departments are going to that. My department has been looking at this, and it's very promising. Understand that the 2.5-inch coupling is not so much to reduce the friction loss as it is to eliminate the need for adapters so you can adapt readily to 2.5-inch hose. It's my understanding, and I have no firsthand knowledge, but it's my understanding that the FDNY permits their engine companies to stretch a leader length, that would be the line closest to the nozzle, connected to 2.5-inch hose. They can use 2-inch hose with 2.5-inch couplings as their leader line that connects to 2.5-inch hose, and they don't have to use any adapters because the 2-inch hose has 2.5-inch couplings. Here's the hydraulic. 1.1/8 tip, 45 psi on the nozzle pressure. Friction loss of 25 per 100 feet. We've got 200 feet laid out. We're on the floor below. We're flowing 250 gallons a minute at 45 psi nozzle pressure. On the 1.1/8 tip, our magic number is 100 psi. Okay, what about 2-inch hose with 1.5-inch coupling? Well, a lot of this depends. All of these figures, now remember, all of these figures are figures that my department arrived at. What you arrive at is entirely your determination based upon the quality of your hose. And we all know that there's a big discussion in the fire service right now about true diameter hose. And when we get into hose like the 2-inch with the 1.5-inch couplings, the 1.75-inch with 1.5-inch couplings, are we dealing with true 2-inch and 1.75-inch hose? A lot of times we're not. So that's going to be a determination that your department is going to have to do by float testing. A lot of departments, Los Angeles, Orlando, Florida, uses this combination. I believe Orlando is achieving the flows of about 250 gallons a minute with this. They're using a high-quality hose. And I'm not sure what the target gallons per minute is in LA, but it is a viable alternative to 2.5-inch hose. Okay, let's talk about the 500-pound gorilla sitting over there in the corner of the room. 1.75-inch hose. Can it be used safely and effectively in standpipe operations? And I say yes, under certain conditions it can. Now, I know to some of you I have just blasphemed Mom, America, and apple pie. But there are a lot of departments that have instructors that advocate using nothing smaller than 2.5, but their own departments are using 1.75-inch hose. Can it be used safely and effectively? Yes, under certain conditions. First of all, what type of hose are we using? That's the big condition. If you're using something like Key Combat Ready that has a friction loss of 25 psi per 100 feet at a flow of 185 gallons a minute, you're flowing a substantial amount of water. Is that true 1.75-inch hose? No, it's not. It's about 1.88. Okay, this is our hydraulics. We stretch 200 feet out on the floor below the fire with a 15/16 tip, and our magic number, as you can see from the math, is going to be 105 psi. Now, where can this be used effectively? Is the building sprinklered? But more important than that, are the sprinklers having an effect? Are they having an effect? In other words, when you open up the stairwell door to the fire flow, you're met with a foggy, steamy cloud of smoke. The other is compartmentation. Is particularly in a residential occupancy, does the compartmentation limit the potential volume of fire to within the size that would be within the suppression capability of 1.75-inch hose? Okay, I'm going to play my own devil's advocate. Well, what if you get up there with 1.75-inch and you find out because of either pressure limitations or the volume of fire, that the 1 3/4 is not going to be adequate. Well, yeah, that's a pretty good argument. And if you're a department that wants to use 2.5 all the time, that's your decision. I'm giving you the information. You take the information. You conduct your flow tests. You look at the standpipes in your jurisdiction in terms of flow and pressure. Look at the fire loading. Look at the type of hose, and you make the decision. I'm telling you, the limitation on staffing is not a justification to use hose smaller than 2.5. If the fire requires 2.5 or a portable master stream, and you go at it with anything smaller than 2.5, you're going to get your people burnt. Remember, the size of the fire indicates the size of the hose. The size of the hose indicates the number of firefighters. The number of firefighters does not indicate the size of the hose. Remember, there's a difference between stretching. This is done dry, primarily on the floor below the fire. You can stretch a heck of a lot of hose dry in preparation to advance it once it's charged. Get the hose stretched out. Then, hopefully, you'll have enough people on the scene to advance that hose, because ideally, once it's charged, you're going to need at least 2 firefighters at the end of that line and somebody at every corner and at every stair landing. Now, let's take a look at another consideration, the amount of hose or the length of your stretch, which has everything to do with the fire location and the distance to the attack stairwell. So, we first, before we stretch, have to locate the fire. Then we will designate and evacuate that attack stairwell. Now, how are we going to do that? We're going to silence that alarm at the alarm panel in the fire command room. And whenever you silence an alarm in a high-rise residential or business high-rise, you must follow up by advising and directing and reassuring the occupants with the public address system component of the alarm system. So in other words, you tell the folks, stay out of the east stairwell, or go to the east stairwell. Whatever your attack stairwell is, you don't want those people in that stairwell. Other ways to find the fire, the annunciator panel. It may be a light. It indicates the floor. It could be a computer readout. Don't think that the first floor you come to is the location of the fire because of reverse stack effect. You may start to encounter smoke in that stairwell several floors below the fire, especially on a hot summer day. So don't think that that's where you need to stretch. You better look beyond where you see the fire on the lowest floor. The other, consider if sprinklers are operated, it's going to make the smoke less buoyant and drive it down again, misleading you as to the location of the fire. What about a thermal imaging camera from the stairwell as you ascend? Yes, especially if the door to the fire apartment is open or there is a fire in the hallway. How about this? We don't know where the fire is, but we've equipped ourselves with 2 100-foot rope bags. We know that the distance between stairwells in this building is 400 feet. So if we extend 2 100-foot rope bags that are tied off in the bag and we clip them together, if we extend 200 feet down a 400-foot hallway and haven't found the fire, doesn't it stand to reason that the fire has got to be closer to the other stairwell? Is there a risk to that? Yeah, you have no protection of a hose line. But it takes a heck of a lot less people to locate this fire, tie off the rope bag, and then give your engine company a clue of how many lengths in the closest attack stairwell. If you run out of rope before you find fire, wind the rope up around the rope bag and go to a different stairwell. If you find the fire, close the door, tie the rope off. What if we encounter heat and smoke from floor to ceiling? I don't know that I want to be using just a rope. So are there other ways of locating the fire? Yeah. You've got a reliable report that the fire is in 555. I also know from pre-fire planning that the apartments line themselves up. In other words, 455 is right below 555. Okay, what are we going to do? Drop down to the 4th floor, find 455. Here's a scenario. You got a fire on the 5th floor. Let's say it's in 507, and I know that the apartments line themselves up. Drop down to 407. Locate and designate the closest attached stairwell. Count your number of doors. Okay, it'll be the 5th door on the right. If all else fails, if the apartments line up, if you can reach the location or the apartment or the office or the area directly below the fire with hose line connected to the standpipe on the floor below from the closest attached stairwell. If you can reach, for instance, if the fire is in apartment 1603 and you can reach with hose connected on the 15th floor, the closest attached stairwell to apartment 1503, how much more hose will you need to ascend from the floor below 15 to floor 16 on your typical return stairwell, and how much hose will you need to penetrate your average size apartment or hotel room? The answer is 100 feet. That's 50 to go from the floor below to the fire floor and 50 to maneuver through the average size apartment. If you can do that, you will have enough hose. There you made it to 1603 plus 50 feet to penetrate to reach fire anywhere in apartment 1603. Now, that officer not only has to determine the amount of hose necessary to cover that fire area, but the number of firefighters on that hose and where they need to be placed on that hose line to keep it going. Bunch everybody up on the nozzle, you're not getting anywhere. That hose isn't getting around that first corner. We're going to have to team up. This is going to have to be a team effort. Now, you know that you're going to have a nozzle team. And this is going to be a group of at least 2, if not 3, preferably more firefighters, especially with 2.5, maneuvering it down that hallway. That third firefighter on the line is literally going to lighten up on that hose line. He's going to position himself or herself somewhere between the attack stairway and the door to the fire apartment. If there is a corner in the hallway, no question about where he or she needs to position themselves, at that corner. Once the nozzle is penetrate, he will take the door position of the fire apartment. In addition, you'll have a mule at the fire floor landing pulling the hose up the stairs and feeding it to the nozzle team. You'll have a mule at half landing that's receiving hose from the mule at the floor below and pushing it up the stairs. It's a team effort. That's one of the mules on the floor below. Now here's some hose packs. And let's talk about hose bundles. You know, I teach at conferences right alongside 2 guys that I really respect, and I hold them in high esteem as greater authorities on standpipe operations than I am. And that is Dave McGrail from Denver and Ray McCormick from FDNY. We all teach different bundles. We all teach different ways of deploying the bundle. So who's right? Who's wrong? Nobody's right and nobody's wrong. I don't have to be right for Ray McCormick to be wrong. What we do in these conferences, in these classes, in these webcasts, we show you a variety of arrangements, configurations, and tactics. It's up to you to look at your staff and your building, your standpipe system, and come up with something that's right for you. Dave likes to teach the Denver load. I'll show you some variation of the Denver load here in this presentation. This is just a regular horseshoe, which nothing wrong with that, especially if it has the female on the outside, because it plays off of your shoulder like a Minuteman. Ray McCormick likes to teach the FDNY load. Works for them. It all depends upon what works for you. Nobody's right, nobody's wrong. Pick what's best for you. Here we're going to deploy 4 Denver loads, 50-foot sections of Denver loads. And we're going to deploy them in a narrow hallway in this configuration. We're going to flush the standpipe, and this is after we've determined which stairway is the attack stairwell. And believe me, it is absolutely essential that you flush. Even after a year, you wouldn't believe the vile stuff that comes out of that standpipe outlet. And don't be afraid to open it up wide. If you have a building without sprinklers, this could be what actually drops the pressure in the system enough to start the fire pump. All right, there's our elbow and our inline gauge. And we are going to deploy 4 Denver loads in this public housing project. If you go ahead and run that video. Take the one on the left.
Keep going. Keep going, keep going, keep going, keep going. Pull up on your other side. Tighten up on that side. Tighten up on that side. Yes. Tighten that up. Keep going. Keep pulling. A little bit more. All right, spread it out. Okay, good. Come on back.
All right, now why didn't we make a W or an S out of that arrangement? Why do we just make a U? You may, depending upon the quality and kink resistance of your hose, be able to make a W or an S. That's going to depend upon the width of your hallway and the quality and kink resistance of your hose. All right. We have changed our way of thinking on the Miami-Dade Fire Rescue Department over the last few years. I was always an advocate, and I was taught to flake out a portion of your stretch in the stairway. In fact, you could go to the floor below or at least to the half landing above. And if the fire floor was clean, in other words, the door to the fire apartment was closed, we would stretch dry to the door to the fire apartment, pull up 50 feet, and then charge the line. We no longer do that. We no longer do that. We stretch out all of our hose on the floor below, and we charge it and go up charged, whether the fire floor is dirty or not. Why? Because most of the screw-up that we see when we're flaking out hose on the floor below and in the stairwell takes place in the stairwell. You know, there's no guarantee that you're going to have a smoke-free stairwell or that you're not going to have competitions of droves of people that are trying to come down those stairs. Now, it is absolutely essential that you do not charge that line until you ensure that the stairway is empty. Twice in the last few years, my department has stretched dry in a clean hallway, and the cops ran right past them and kicked in the door to a fire apartment, and it was pandemonium. You will never go wrong with charging the hose line on the floor below and going up charged. Additionally, how in the world are you going to accurately adjust your pressure in the line, looking at your inline gauge, and you have to have the nozzle right there with you. Otherwise, if you charge the line when the hose is in front of the doorway to the fire apartment, you're either using runners or you're using radios, and that is not a good time to rely on using radios. So that's just what we do. We'll never go wrong. We will not leave that attack stairwell, whether the hallway is clean or dirty. We're going up with a charged line. And we are not flaking any uncharged line in the stairs. Why? We know from experience that's where your kinks develop. Remember, there's no guarantee that you're going to have a smoke-free stairwell with reverse stack effect. How are you going to detect things like this? A potential kink here, or a kink here. Now, we lay everything down on the floor below. We charge the line within earshot of the firefighter on the valve wheel, and we adjust our pressure. We mask up everybody on the line. If anybody passes anybody, you haven't done your job. Everybody up the stairs like a conga line. The last two guys on the line, if it's 2.5, are the guys on the floor below. The next guy drops off at the half landing. The next guy drops off at the fire floor landing. And there's a nozzle team member that is actually lightening up on the line. He's somewhere between the attack stairwell and the nozzle firefighter and the officer. This is the use of that bow ring. If you've never used one, you use kind of a ratcheting action, and it really, it's like a strength multiplier, especially if you cannot use your legs. If you're down on your knees and you can't use your legs. If you can use your legs, pick up that 2.5-inch line, hold it to your waist, and use your legs. But if you can't, it's going to wear you out pretty quickly. Again, the nozzle team is not going to make it to the fire without a mule at the fire floor landing. There's the third guy on the nozzle team, and he's in the foreground. In the background, you see the firefighter at the fire floor landing. You've got a mule at half landing, and you've got floor below mules. Now, as the hoses advance, the amount of hose on the floor below diminishes. You might be able to bump one of those mules on the floor below up on the line. Now, here, the officer is looking at a stretch where we're going to have to go through an elevator lobby. So he's doing his job as an engine company officer. Not only the length of line, but the amount of firefighters and where they're going to need to be positioned to get through this elevator lobby. All right, Rusty counts 1 there, 2 firefighters there to get the hose line through the elevator lobby. There's your mules in the elevator lobby. There's your number 3 guy on the nozzle team, and he's humping the line at the doorway so they can advance into the fire apartment. Okay, we've knocked down the fire. Could we bring up a smaller diameter line? Yeah, we could. Now, if you have good pressure, I'm not totally infatuated with the Cleveland coil or Metro load, but in this case, this situation, post-control, could we, in a small space, spin off the tip of that 1 1/8 or 1 1/4 tip, connect up the 1 3/4 Cleveland load, lash the bail open so it doesn't get accidentally kicked shut, and then finish the job with 1 3/4 line. Okay, here we're going to deploy 4 modified Denver loads of 2-inch hose with 2.5-inch couplings. Again, we'll flush. We'll lay the hose out, and in this case, this is a department that uses a Y and an inline gauge. The idea with that pigtail is to allow you hose to connect up into a cabinet like you would have to do in older buildings. The cabinets you're not going to find the cabinets in the stairwells. The cabinets of older buildings, at least in my jurisdiction, would be outside the stairwell. And you may need a short section of 2.5 or 3-inch hose to extend out of that cabinet. So if we go back to this picture here, where you see him flowing, okay, that is not in the stairwell, nor should it ever be in the stairwell. We don't want a cabinet in the stairwell. Okay, so here the fellas are making their connections. In this case, he's going to pull the coupling down the hallway. And in this case, this is key combat ready 2-inch hose with 2.5-inch couplings. We will make a W out of this hose, not just a U, but a W. Why? Because the hall is wide enough and the hose is kink resistant. We're going to show another video. This is a procedure for flaking out hose. This was done just recently in our training tower, where you can't pull 200 feet of hose back 100 feet, where you have 200 feet of hose, but you have only 50 feet or less to stretch it out. So let's go ahead and show this video, flaking out within 50 feet. Okay, and that's where we would charge our line. I would keep the firefighter that stretched the hose out at the end of the hose there, because that's where your kink is going to be. And then I'm going to show you here in the next slide or two. Okay, there you see your Y, there you see your nozzle, there you see your coupling, which marks half the stretch. Now, do you see what the firefighter is doing here? He's dressing up the hose in the hallway so that the portion of the stretch that is closest to the nozzle rides over the portion that is last to go up the stairs, the portion that will remain in the hallway the longest. All right. You got yourself a high-rise fire. You've got a group of firefighters you've never drilled with, you don't even know, and you got to get this operation going. It's going to take leadership, and it's going to take discipline. Okay, so this is what I would do if I was faced with that. Line your people up on the line. Number one, you're on the nozzle. Number two, you're the officer. Stay behind the nozzle until you get into the hotel room or office, wherever it is. You're going to be the doorman, but you'll be operating somewhere between the stairway and the door to the door to the fire area. Now, if it's a corner, it's a no-brainer where he or she's going to be. Now, how do you know? Because you familiarized yourself with the floor below. That is not to say there's no guarantee that the floor below might not have some smoke in it. Okay, brother, you're not going to the fire. You are staying at the fire floor landing, pushing hose to the nozzle team. You, number 5, you're going to stay at the mid-landing, and you're not going anywhere, bro. You're staying right here on the floor below, dragging that hose and pushing it up the stairs. Now, who's important? Whose position is most important? Every position is equally as important. If everybody doesn't do their job at that position, the job is not going to get done. It's not going to get done. It's teamwork. And the way you get that teamwork is through practice and repetition. All right. As I said, on my department, we're going to charge the line and adjust the pressure right at the valve wheel, and then we start up the stairs. The same, the mule on the fire floor landing, the mule at the half landing, the mules on the floor below. Positions himself somewhere in that hallway to lighten up on the line. What you're looking at in the foreground is the third firefighter on the nozzle team, and in the background is the mule on the fire floor landing. All right, they make their attack. Now, this is a load. I have to give this credit to Captain Kevin Story. He's on the Houston Fire Department another highly respected individual, especially when it comes to engine company operations and standpipe operations. I don't know that Houston uses this particular load, but I know that Kevin's volunteer company does. I was quite impressed with the simplicity of this load, and if it looks like it is the same width as your cross lay, that's no coincidence. So let's run this video of the Houston load. As I said, it may not be proprietary to the Houston Fire Department, but it came from the Houston area, courtesy of Captain Kevin Story of the Houston Fire Department. Go ahead.
Okay, Ralph, come back. Come on over here by me. Okay, good.
Engine 48 quarters, 15 left hand. Are you on me?
Okay, let me back up just a second. I want to talk about taking your time and getting it done right the first time. If you notice, in none of these videos were these guys hurrying, nor should they. They don't have enough firefighters on that floor below in the beginning stages of this operation to advance the line. They're going to stretch this hose out, get it ready. Hopefully, they'll have enough firefighters in short order to advance the line. The other thing is, consider once you open up the door between the fire floor and a dirty hallway, you're going to turn that stairway into a chimney. Now, there's departments that have learned the hard way, that have actually, they've opened the door prematurely, filled that stairway full of smoke, and actually injured or killed people in the stairway. Especially in buildings where you cannot return to a intermediate floor. Once you get in the stairway, you have to go all the way to the ground floor. We would hope that the alarm system would disable any kind of locks in that stairway. If you start with inadequate amount of people trying to advance a hose line, particularly a 2.5, I'll tell you invariably what's going to happen. You are either going to become physically exhausted and or run out of air. You're going to crap out. You're going to follow the hose line down into the stairway to the floor below, and then hopefully you can change your bottle. Now, what have you done? Have you made things better or worse? You didn't reach the fire. You didn't get any water on the fire, and now you've wedged the door open with a charged hose line. Would it have been wiser to wait until you have adequate personnel? And ideally, in an ideal world, you would have a team. That's your mules and your nozzle team. You would have a backup when they become exhausted or exhaust their air supply, and you'd have a backup to the backup. Now, that's an ideal world, but if you start with inadequate people, you will fail. Don't attempt a stretch that requires, or an advance, I should say, that requires more people than you have. You will run out of air. You will fail. Smoke will spread, and you will be feeding oxygen to the fire through an open stairwell door. Okay, we're doing pretty good on time. All right, talk about some high-pressure pumping. I am by no means an expert at that, but I'm quickly learning it because I'm a student of the fire service. South Florida is undergoing a huge building boom, in my territory along the Atlantic Ocean, they are knocking down every mom and pop 2, 3, 4, 5-story buildings and putting up these huge condominiums and luxury hotels. So we better get used to it. So in this particular building, we attended a flow test, and the sprinkler system, standpipe system contractor, already had the pressures posted. And I said, well, that's great. Let's go ahead. And he explained how he has pumps in this building. There's all the pumps are on the same floor, at the few floors from above the first floor. And I said, well, that's all well and good. Turn your pumps off. In this particular building, the one pump pumps into the other pump, and they would pump in series, almost like a tandem or relay pumping operation, but the pumps are on the same floor. And I said, shut your pumps off. We're going to pump into the FDC. He said, why would you do that? I said, well, sir, I says, what if the pumps don't operate? He says, that's highly unlikely. I said, sir, you know what the storm surge is going to be in just a minor tropical storm? I mean, the Atlantic Ocean? We're going to lose those fire pumps. So he shut them down, and he was very nervous about it because we pumped at a high pressure. So in our first flow test, we used a 2.5-inch line because that was the hose that could take the highest pressure, just as a point of reference. If you're pumping a fire department connection at high pressures, you want a hose that has a high service pressure. For instance, your key combat ready, your service test pressure for key combat ready, 2.5 is 500 psi. Its burst pressure is 1200 psi. The 3-inch is 400 psi service test, and the burst pressure is 1200 psi. So let's take a look at what we did here. Okay, just to be sure, we've cordoned off the area. We connected up on discharges opposite the pump panel. We marked our couplings in case they would fail. We lashed the couplings or the hose lines to the apparatus, again, opposite the pump panel so we wouldn't endanger the engineer. And our initial test was at 350 psi, and we were flowing 500 gallons a minute, so we were doing pretty well at a fairly low RPM. Now, we were not flowing continuously, and at that pressure, you will heat up your pump in a New York skinny minute. So it was recommended that we flow a minimum of 100 gallons per minute. We took off the nozzle from our 100-foot bumper car fire line, lashed it to a sewer grating, and kept flowing to keep our pump cool throughout the duration of the test. There we are on the roof. We're well over 600 feet in the air. We're trying, if you'll notice that parachute, that's a paraglider, and our goal was to knock that guy out of the sky. Just kidding. Anyway, we did achieve at a pressure of 350 psi. It took us to flow 2 2.5-inch lines with 1.1/8 tips from the two most hydraulically remote outlets on that standpipe. There we're using a pitot gauge to measure the flow. Now, this is another test that was conducted by our brothers in the City of Miami Fire Department. This is an 82-story building in the Brickell area of downtown Miami. This is the tallest building in the southeast United States. I got to give our brothers on the city a lot of credit. They've already purchased a high-pressure hose that has a astronomical service test pressure. And we go. All right, this is a temporary standpipe. It's a construction standpipe. and it has only 2 zones, but the target pressure was off. It ended up that they needed close to 500 gallons a minute to get the flows on the upper floors. Now, they lashed their high-pressure lines, and in this case, they conducted a tandem pumping operation. In other words, they connected an engine to the hydrant with a short section of suction hose. That engine pumped 250 psi into the engine that pumped the FDC. Now, what you see here is the mechanic is accessing the intake relief valve of the engine that is receiving the water and pumping the FDC. And he is going to adjust that intake relief valve so that it does not dump water. It can receive the pressure at 250 psi. So here you see the pump panel of the engine pumping the FDC. It is receiving the water at 250 psi, and it is pumping the FDC at just a little bit south of 500 gallons per minute. Now, this is something that works for us. I'm not saying it'll work for you, but it's something to think about. We use a 4-way valve in our 5-inch hose forward lay evolution from hydrant to fire. The idea is if the flows or the length of lay makes the friction loss excessive, we can have another engine go to the 4-way valve at the hydrant, take suction at the 4-way valve, pressurize the supply line, and overcome the friction loss in the supply line. So how about this? This engine here is pumping 500 gallons a minute into a fire department connection. Okay, and it is receiving water at a residual pressure from the hydrant at 50 psi. That's what the hydrant is giving us at 500 gallons a minute. So what about if we brought a second engine in and it took suction at the 4-way valve, and we connected LDH at the right side, large diameter discharge, and pressurized the supply line through the 4-way valve at a maximum of 185 psi, which would be your maximum pressure for LDH supply hose. Now, this is the master intake and pressure gauges of the apparatus that is pumping the FDC without doing anything, without increasing the throttle one bit. Just by increasing the intake pressure, we have gone from a pump pressure of, let me back up. We went from 250, and that was at 50 pounds residual, to 400 at about 160 pounds residual. Now, your limiting factors here are going to be your relief valves. One is going to be on your master intake valve if you happen to have this type. The other is going to be on the intake side relief valve that's plumbed into your pipe, your pump rather. The one that says "do not cap," that's the one you're not supposed to cap. The reason that there's threads on there is if you were in a relay operation and you were subject to either icy conditions or muddy conditions in a relay, you would put a line on that and bleed off your water someplace else. Okay, that's another test. Okay. As fire officers, our objective, our strategic objective, in other words, what we're going to do is to protect life. There's no question about that. Our strategy is to protect life. However, in a high-rise building that cannot be readily evacuated in short order, maybe, just maybe, the best way to protect life is to take the harm away from the people by using the tactic of controlling the fire. In other words, in a large building, it's impractical or impossible to take the people away from the harm in a timely fashion, we might be better off in many cases taking the harm away from the people by putting water on the fire. What I like to tell our folks is, when you're stretching hose line and advancing it off the standpipe in an occupied multiple dwelling or office occupancy, you are on every bit as much a life-saving mission as if you were dragging an unconscious person down a smoky hallway. You're in life-saving mode, taking the harm away from the people that otherwise cannot evacuate themselves, like this nice little old lady. Is it risky? Yes, it is worth the risk. But everything we do is in accordance with a risk-reward analysis, and in this case, it's definitely worth the risk, because look at the reward. You're protecting life by taking the harm away from the occupants. This is my website, bill@gustonfiretraining.com. I've waited these last few minutes. We'll answer a couple of questions, but I promise you that I will answer each and every question. And one of the beauties of waiting to the end is that there's no way that I can possibly answer all the questions. So the ones that I don't have the answers to, I'll be calling my friends and my colleagues and finding the answers to them. So, because I may not have all the answers. So, Peter, do you want to go over some questions?
Yeah, Bill, thank you once again for this presentation, and thanks to everybody for sticking in there and supplying these questions. And a thank you to Key Hose again. You can get at them at keyhose.com. So I guess we'll start at the beginning. Tim from California asks, or he says rather, that we've always been taught to pump to the fire floor. However, with the PRVs in place, we have to pump to the topmost floor. Is that correct?
Or the zone. He's absolutely correct. Those fire pumps do not know what floor that fire is on. That fire pump cannot count the number of floors, multiply times 6, and add 100, especially with PRVs. The PRVs are either field or factory adjusted to compensate for the pressure, and that pressure is what is necessary to achieve a flow of 500 gallons per minute at 100 psi from the two most hydraulically remote outlets. And that's typically the roof. The man is absolutely correct. You pump the demand pressure. Now, if they're zoned, there's only going to be, if there's 2 zones, there'll be 2 demand pressures. If there's 3 zones, there'll be 3 demand pressures. If there's anything good about PRVs, it does kind of simplify, because you're really only pumping 1 pressure. And if I could expand on that, my buddy from California, if you pump below the demand pressure and the building has PRVs, you will be hard pressed to get an adequate flow from a first floor outlet, because the entire system is either factory or field adjusted for the pressure necessary to achieve the 500 gallons per minute at the primary standpipe and 250 at any secondary standpipe outlets, typically at the roof, and that is at a minimum of 100 psi. Next question.
All right, so we'll ask same one from Tim. Part 2 is, can you explain how the system pressure on the fire pumps work as it relates to the pump discharge pressure to the FDC, so we can overcome the check valve?
Wow, that is so spot on. There is this notion that we are somehow adding or supplementing water when we pump into a fire department connection. That is a misnomer. That fire pump is pumping a certain pressure. Now, it's a curve. It's not like an engineer can raise the throttle. It has a curve. The more the fire pump pumps in terms of volume, the lower the pressure is going to be. But if the fire pump is generating 230 psi, and you, as your engineer, pump the fire department connection at 220 psi, you will be pumping up against a closed clapper valve. It is not until you exceed system pressure that the fire apparatus pumping the FDC will overcome system pressure and open the proper clapper valves to be able to supply the system.
Okay. With that, I'm going to jump down to another one about the FDC. And James asks, in a building with a fire pump supplying the standpipe, do you recommend using the fire pump or the FDC to supply the standpipe?
Wow. That is one of those things like the discussion about the size of hose. Let me give you two arguments. I can talk out of both sides of my face. You have a building with a demand pressure on the high zone of let's say 420 psi. You have pumps operating in series throughout the height of the building and tanks on the roof with pumps actually pumping down. Now, do we want to pump 430 psi into this fire department connection when the chances are pretty good that the pumps are going to do their job? You know, is there an inherent danger in pumping 430 psi? Yes, there is. So there's one school of thought that says treat the building like it does not have a fire pump because you cannot rely on them. Treat it like it doesn't have a fire pump. The other school of thought is get everything hooked up. And remember, Peter, we said, we're not going in to harm's way until we have flowed the line and made sure that our inline gauge and the quality of the screen is adequate, both in terms of PSI and in the judgment of the nozzle firefighter. So that's two schools of thought, and we could discuss that ad nauseum. They both, the school of pressurizing the FDC as if there was no fire pump, and the school that says get everything hooked up and then pump it. Two schools of thought, both have valid arguments.
All right. I'll take another one. This one from John in Charleston asks what your opinion is on using an increaser to support a 2.5 line off of a Class 2 outlet.
Oh, man. I'm getting the impression that the Class 2 outlet is 1.5 inches. Man, I mean, if that's all you got. You know, the class, just for, I know that our buddy in Charleston knows, but for our other listeners, a Class 2 outlet is your hose cabinet that is not in the stairwell. Would I ever use it? As I said in my previous webcast, what if you're in a hospital and you got a smoky fire in a linen storage closet? I might use that cabinet. I might use that Class 2 outlet. In that case, I can see where if he brought up 2.5 and he wanted to stay in between the smoke barrier doors in a healthcare facility, knowing that if he opens and he comes in and opens those smoke barrier doors, that he's going to contaminate the intensive care ward, yeah, I could see him using that increaser for that. Is it ideal? No. We know that. We know that. But he's doing the best he can.
Okay, and take one more. I know we're running close to the time, but Jeff from Concord asks, any perceived pitfalls of using 100-foot lengths of 2-inch line in place of 50-foot lengths, as there's fewer connections?
No, there are no pitfalls. Okay, the only pitfall that I could tell you is that I'm an old timer. I'm an old bull. I like the feeling of that 50-foot coupling going through my hands and setting it at the doorway. Other than that, there's a lot of departments. Our brothers on the City of Miami Fire Department just equipped all of their companies with 75-foot sections of key combat-ready 2-inch with 2.5-inch couplings. For the longest time, my department was operating with 100-foot sections. The advantages is weight, and also less possibility of the couplings hanging up on a stair tread or a corner. So he's spot on. There's some advantages to that.
Okay, and I think per our agreement with Tammy, we're going to have to cut off, but There's so many good questions coming in here, Bill, and I know you said you'd answer them, so we'll
and I
provide
will,
them to you
Peter.
offline.
I will, Peter.
Yeah.
And so I appreciate the opportunity, and for all of you that have questions, you know, you're the students of the fire service. Who's ever watching this webcast right now, you're the 10%. You're the 10%ers that have your heart and your head in the job. So I want to just thank you. I want to thank Key. I want to thank Tammy. And I want to thank our listeners. And I also want to wish all of our listeners a very happy Thanksgiving. I hope you have a lot to look forward to be thankful for. And may God bless you and keep you safe in our most noble profession.
Thank you very much, Bill, and thank you all. And we'll catch you next time.
Well, Peter, we're off now, right?
I think now we're